there was a question that if you have a family of surfaces z square equals to kxy, then you have to find the family of surfaces which are perpendicular to this. Now, we have a process to reduce this problem in our well-known Lagrange method. Let's do this. First of all, we have to keep the constant term k in right hand side and the other terms into left hand side. Like this, z square divided by xy is equals to k. Now, let this term as a function of xyz, f of xyz. Now, we have to compute the partial derivative of f with respect to x, y and z. So, let's compute. If we compute the partial derivative with respect to x, we will get z square divided by x square y. Similarly, we will get fy equals to minus z square divided by xy square and fz by 2z xy. Now, our next step is we have to take these values and put them in the equation fx t plus fy q equals to fz. Here we all know the Lagrange method and we are aware about the notations small t and small q. This small t denotes the dz dx. It means partial derivative of z with respect to x, and small q denotes the partial derivative of z with respect to y. Now, if we put the values, the equation reduces to zx. You can easily check that it reduces to this z by x into p z by y into q equals to minus 2. If you write this more simply, then it becomes 1 by x p, now 1 by y q minus 2 by z. Now, this is of the form, so capital P small p plus capital Q small q is equals to r, where p, q and r are function of x, y, z. Now, I can solve this using well-known Lagrange method. So we can write from this that dx divided by, what is the coefficient of small p? That is 1 by x. So 1 by x dy, what is the coefficient of q? 1 by y is equals to dz. What is the capital R here? From this equation, if we compare these two, that is minus 2 by z. Now you can solve this by taking any two of these three. I am taking first two. From taking first, I am getting this x dx equals to y dy. If we integrate it, we will get x square minus y square is equals to c1. Now, I will take the first one and the third one. From this, I will get, after integrating, 2x square plus z square is equals to c2, where c1 and c2 are arbitrary constant. Now, if we get two solutions using Lagrange method, we can write the general solution as phi of x square minus y square, comma 2x square plus z square. 2x square plus z square. This is the equation of family of surfaces which are perpendicular to z square equals to kxy. Now I will repeat the process once. If we are given a family of surfaces, then we have to write the equation of the surfaces like this, that constant terms are in one side and other variable terms are in the other side. Now, if we get something like this, that f x y z equals to some constant, then we have to take the partial derivatives of f with respect to x, with respect to y and z simultaneously. After that, we have to put these values in this equation, fxp plus fyq equals to fz. Now it will reduce to this form. This form is well known. We reduce our PD equation to solve using Lagrange method. Now, after the equation reduces to this form, we will apply the Lagrange method and we will get the general solution of the surfaces which are perpendicular to our given surface.